Next is Vittorio Loreto, who is full professor of physics of complex systems at Sapienza University of Rome and member of our faculty here in Vienna. He is presently director of the Sony Computer Science Lab in Paris, where he heads the team on innovation, creativity and artificial intelligence. Vittorio is known for his innovative approaches to physics outside physics. We are very happy that you are here. Please take the stage, Vittorio Loreto.
Okay, thanks a lot. I'm very happy to be here today. And if I had to summarize what I'm going to say, I guess that would be very simple. So the point is trying to convince you that the complexity is science, at least, the way in which we understand it. I'm not sure, I understand it completely, but at least the way in which I understand it can, and probably I would argue that we should somehow, game the future. When I say game the future, I mean trying to face difficult problems. And of course, all the challenges we all mentioned all the time, we also mentioned a lot of time today. But very often, all the challenges we mentioned remain confined in the first paragraph of our papers, because of course this is the motivation for the importance of our contribution. But then, they disappear, in the paper, and at the end we end up with something which is very interesting, okay, beautiful, as Costantino would say, but probably not related to the problem we had in mind, okay. So the point is, I guess we can do something, okay. The problem is whether we want to do something. So my contribution today will be showing why I think we can, forget about Obama, of course, but perhaps tomorrow we can discuss whether we want to go this way. Because the point is, going this way is not easy. It implies a strong responsibility. We want to do something, okay? Otherwise it doesn't work. It implies also rethinking a little bit the way in which we do science. Somehow moving from a sort of competition-based science, okay, which is interesting, has been interesting for a lot of times, to a more cooperative, or at least a little bit, okay? Because of course, these are very, important problems. We can solve them. I guess we can give a contribution. And we cannot pretend we didn't know. Okay, but I guess we have all the tools available to address these problems. So let me say first, why I think we can do something. Okay, I guess there is a convergence of a lot of ingredients. And I guess a very partial reconstruction would say that the main ingredients of this would like to be perfect story could be these two, data and, when I say artificial intelligence, I mean all the tools we use to monitor data, to analyze data, to extract features, to basically transform data into information and knowledge. Okay. But this cannot be the end of the story. I guess we all agree about this, even though sometimes we forget. So it's not the end of the story because, okay, let me give you an extreme example and then we tell you why this is not so extreme. This is the middle of Australian outback, Volvo self-driving cars. This is Guardian and reporting last summer that these cars get basically confused by kangaroos. Of course, Volvo is Swedish, and the kind of animals, trained, the machine were elks and caribous, but definitely not kangaroos. So the cars simply stopped. They didn't know what to do. Okay, and why? So, because actually, kangaroos was not part of their training. And even if now, you can say, okay, now kangaroos are part of their training, there could be still another species, as Francesca was mentioning, that could be new. So the point is, when we try to face a complex problem, we are basically moving at the boundary between what François Jacob would say, the actual on the first side. So what we know, our experience, the data we know about the past, basically, okay? And then the set of possibilities. So the set of what could be possible. And of course, we have a very hard time tracking this space of possible, even charting it. Okay. So that's the key point. So how can we predict something that never occurred before? So from the probabilistic point of view, Francesca highlighted this morning, where is the conundrum? Okay. And so the typical solution we use is to look at the future with the eyes of the past, which means we try to collect a lot of data and we pretend that with this data we can still predict the future. This is not working, as you have seen, for machines. It's not working for humans because, for instance, weather forecast is not working with inference, looking at the time series of past events. It's working because we have a modeling scheme, a representation of how the atmosphere is moving, and then data driving this modeling scheme, we can hope to make predictions working. So we need our intelligence. So I would say that the ingredient missing in the previous slide was human intelligence, which means our ability to read the environment, come up with generalizations of what we see, something new, okay, and then come up with modeling schemes. Okay. So these three elements should be coupled. Of course, sometimes we can be helped by data in guessing what is the right modeling scheme. For instance, this is a case in which you can use basically maximum entropy principle in order to infer what are the coupling parameters among elements in a city. Okay, you can go through this, you can get a lot of data about this, and try to come up with a sort of Hamiltonian for a city at the local scale, at the global scale, in time, so you can do a lot of stuff, but this is not the point. So the point is, we know how to construct modeling schemes, and even before this, representations of what is out there. And representation also means the possibility to make generalizations. So of course we are coupling modeling and data science, roughly speaking. This is we do already. Okay. Sometimes we forget the modeling part. Okay, there is someone pretending that this is not important anymore. I would assume that this is still probably the most important part in this picture. And, but I guess we can add another element, which is down there. So the possibility to run experiments on the kind of problems we are investigating. For instance, involving people, okay, in a sort of playful activities, still very important from the learning and awareness point of view, and the scientific point of view. For instance, in activities like this one, so this is an experiment we made a couple of years ago, less than a couple of years ago actually. People are supposed to construct a city with Lego bricks. They are completely free to do whatever they wish. The interesting part is actually there is a monitoring system, which is camera and sensors, monitoring what is going on down there. Okay? And the monitoring system, like a satellite, is gathering data about the evolution of the city. But then this is actually feeding a modeling system. Okay? So there is an underneath model. And through this model, you actually get, an evaluation of how good is the city from very different points of view. And then you feed back this information to people through the monitor you have seen up there. So people look at the monitors and try to understand whether their strategy to drive the city are correct or not. Then they steer, the strategy, they start to do something else. They can come up with completely new solutions for this. So you see, this is just one example, but the basic ingredient here are two possibilities. One is the possibility to use data to assess the present. So understand what is going on there. Okay, this is already very important because from the learning point of view and the awareness point of view, it's not always trivial. But then the point is, once you learn something, you can try to project yourself into the future and try to construct scenarios, which are tested, by the system, and you get a feedback out of it. So if you zoom out a little bit, so the kind of infrastructure I'm thinking, the name we invented is Gaming the Future, but okay, we can invent a better one, is a sort of general infrastructure in which you have an interface. The interface can be a physical one, like the Lego interface you just saw, or could be a virtual interface, like a video game, like a sustainability game. Okay? So people are playing. While they play, they learn something. Okay? But while they play, they also get a feedback about the intended consequences or unintended consequences of their actions. So somehow there's a feedback loop between what they do and the kind of ideas they put into the system and the way in which the system can actually evolve. So one important point about these infrastructures is they're not supposed to be decision theaters. So you don't push a button and say, okay, what should I do now? These are intended for awareness. So what happens if? So somehow you're playing the game, what if? What happens if I construct a new metro lines in this specific place? Okay, is this improving the situation or not? And you see, there is a very strong contribution of modeling here, because without the right modeling, of course, all the feedback can be completely off, and then you get nothing out of it. It can be a nice game, still a nice game, but completely out of focus. So I conclude here, and so I repeat, I think the tools we have, complexity now, are very, very interesting. And I guess they are, right there, in the right combination to address very important questions. I guess we should be brave, in this. And we should somehow try to move from a reward system in which our reward is yet another publication, yet another citation, and the reward should be more, this is working. This is solving a problem. And of course, this implies to be less selfish. But of course, we know, this very interesting position. So I stop here, and thanks a lot.